So, what the study showed me that is that if you look at this on a macroeconomic basis, and this is important for economic policy setting, which is going to be a very important process post-Copenhagen with national allocation plans in the coming months, we see we've got net value added of about 3 cents per kilowatt hour. And what does this mean? If you actually put this into the economic models here, it means if you look at your 3 scenarios, baseline, accelerated growth, and if you actually take money out of the system and put it into feed-in tariffs, what happens in these low cases or high cases? You create massive economic value for Europe. You create value. When we talk about feed-in tariffs is taking money out of one set of pockets and putting it into the other set of pockets, but overall, in those trousers, it's circulated and it's creating value for society. And that is a very, very important message and understanding, because a lot of the political debate goes, oh, we're subsidizing this, and this is costing us money. It is not. We are creating political and social and economic value added, and the quicker you do this, the more of that you create. Now that's all a lot of the top-down stuff, looking at the economics, but 12% went for it. Can we actually get that into the networks in Europe?
Before going to the network, let's just have a close look to how did we look at the 27 member states, plus we included also Turkey and some northern countries in that. And we looked not to each of the 27, but we picked the 10 biggest ones in terms of sunshine and terawatt hours electricity used in these countries. And this shows you, first of all, which countries we looked in much more detail, as you will see in a moment, because you will see it is not just to add 10 or 100 gigawatts without asking what will be the implication for that. So that is a very important exercise which we did together. And for just the paradigm shift scenario here, these are the numbers which would be necessary in total in order to get them to the 390 gigawatts cumulative in Europe by 2020 and producing these 460 terawatt hours of electricity. So it is no surprise that those countries with the biggest electricity usage will have to bear most of the gigawatts to be installed, because otherwise we would have to transport too much around Europe. And we look also in more detail what that could mean. And one important finding here was, for example, that it makes a lot of sense to have PV really localized and not distributed and not localized, what some people would argue, just in the south and then distributed to the north. It makes a lot of sense to utilize PV by its means of modularity and being decentralized all over the place. So, and this then would result in this electricity production. And this here tells you, okay, the penetration of photovoltaic kilowatt hours on the total electricity consumption becomes really an issue. And this issue was discussed in much more detail in the next picture.
Yeah, this is quite straightforward. We know that photovoltaic electricity is produced when the sun is shining. It tends to be during the day. And you have a certain peak loading during the day, so you have a nice correlation. And if we're talking about 18% and all of this sort of thing, in terms of contribution of photovoltaic, does that work with base loading profiles, with overall load profiles? So we looked at this on a country-by-country basis. We went down to the level of looking at the weeks, the daily, the hourly load profiles. We looked at what is driving this. If you see just air conditioning, we have global warming. It's getting a bit warmer, so you have to do a little bit more air conditioning, etc. You have some positive correlation loops here. Is driving a lot of this peak demand. We're all having more luxury, we're all using more consumer goods, etc., etc. By the way, if electric cars come, they'll also be. And we've basically looked at how must photovoltaic actually feed into electricity usage. And you actually get to some very, very interesting and also non-directly intuitive application of the technology. Could you say something about that, Wilfred?
So we looked in detail here for an example of a national average electricity demand profile and simulated the PV production. So the left picture shows you the daily demand on an average winter week. Well, on a winter day, quite obviously, photovoltaic is not producing so much electricity as we all know. So you just get a little bit off the peak, but not more. If you take the average on a summer weekday, then if you go to a high penetration, you start already to dig into the medium and even to the base load. And if you even add again more gigawatts in the country, then all of a sudden you dip deeply into the load profile. So then you have the choice: either you stop base load systems, which on an economic basis is not the best way to do, or you waste these nice kilowatt hours, which are nicely produced at that point in time. So obviously, once you go above this magic number of about 6%, which we presented before, our accelerated scenario, then you have to do something in addition, because from then on, you not only add another gigawatts, but here you really have to do something in addition, Anton.
You need other technical aspects. Let me just also make one point, because I think you said it exactly. As soon as you go above 6%, ladies and gentlemen, photovoltaic in Europe is way under 0.7%. We will need years to reach that, and as soon as you exceed 6%, you actually get into what we call a paradigm. So when we need additional technical aspects, you're going to need the combination of decentralized photovoltaic systems, of advanced power controllers. We've already got them in places like Italy. Smart meter systems. Many of the world-leading companies, technologies, are developing this storage solutions, where a lot of these things are coming on. And it gives a lot of advantages if you can harness these things. And we'll probably need them from about 2015-16 onwards to reach the paradigm scenario. That's load management, reduction of investments on the grid, outage prevention, etc., etc., etc. Now, these are technologies that are coming. It's just a question of the timing and the economics behind this, but I think there's very high confidence that they will be put in place when we need them within this paradigm scenario.